Hello guys, in this video we are going to discuss the solution to the problem maximum total damage with spellcasting which appeared in the Leetcode weekly contest 402. So in this problem we have been given an array of powers and what we have to do is that we have to find the maximum possible sum of powers that we can choose. Such that it satisfies these conditions. So now you will ask me if there weren't these conditions, we could have just took the sum of all these powers and it would have been the maximum possible sum. But since these conditions are there, we have to follow these conditions and take the maximum possible sum of powers. So the condition is that if you take a power of I, we can't choose power of I plus 1, power of I plus 2, power of I minus 1, power of I minus 2. So if we for example, if we choose a value with the power 2, we can't choose power 0, 1 and 3 and 4. So if we choose a power with the value 2, we can't choose the powers with the values 0, 1 or 3 and 4. We can't choose any of these values. So we have to find the maximum possible power that we can get by satisfying this condition, right? So most of you have guessed from the problem statement itself that it's a DP problem. It's a pick and not pick DP problem. So we will try to either pick or not pick the powers. So we have the option to either pick or not pick a particular power, right? So it's a standard DP problem, but the twist is that the implementation part. So most of you have guessed it would have been a DP problem where we have the option to choose a power or we have the option to avoid that power. But the problem comes when the implementation part of it, because if we go ahead with the normal implementation, the time complexity will be large and the space complexity will be large. So how I implemented this problem is that, and I will show you why we can't directly implement the pick and not pick implementation. I will show you in 1 second. So I will show you test case first. So this is a test case. Okay, this is a test case in the problem. It's a hidden test case, I guess. I mean, when you get a wrong answer, I got this test case. Okay. So this is the test case. So what I did initially is that I sort these values in the ascending order, and then I create a new array such that inside the new array the elements will be such that the first so inside this new array the elements will be in the pair format. So there are I arrange them in a pair format, pair. So inside a pair, the first element will be the value and the second element will be the number of occurrences of that particular value. So the first element is 2 and the second element is 2. So 2 occurs 2 times. So inside this array 2 occurs 2 times, right? So that's why I wrote 2 over here. And the second pair is 3, 1. So 3 occurs 1 time. So if you check inside this array, you will see that 3 occurs 1 time. And 5, 1. So 5 occurs 1 time in this array. And 7, 1. 7 occurs 1 time in this array. And 8, 1. 8 occurs 1 time in this array. 9, 2. 9 occurs 2 times in this array. 9, 2 times in this array. And 10, 2. 10 occurs 2 times in this array. That's why I wrote it in this format. So it will be more easy. I thought if I write like this, it will be more easier. Because when we choose a particular value, the only restriction is that we can't choose the values satisfying these conditions. So when we choose a particular power of I, we can't choose power of I plus 1, power of I plus 2, power of I minus 1 and power of I minus 2. So it doesn't form any restriction on the value that we already chose. So if we choose power of I, it doesn't mean that we can't choose power of I again. So the optimal way will be so if we choose a particular value, taking all the occurrences of that particular value will be the most optimal, right? So since we have already chosen 2, it is not logical to leave the other 2s inside this particular array. So if we choose a particular 2, we will also include all the other 2s in this particular array to our total sum. So it's more logical. That's why, so for more easier adding into the sum, I grouped all the occurrences of all the values together. Right. And now I will show you why the normal DP can't work. So the normal DP, why can't the normal DP work? So if we choose a particular, if we are at the ith index, so we have the option to either pick this ith index, the value at the ith index, or not pick the value at the ith index. Not pick the value at the ith index. Right. So if we decide to pick the value at the ith index, we have to check whether the value that we last chose, the value that we chose before picking the last value we choose. So we are iterating through the array, right? So we may have chosen some values beforehand. Before reaching this particular ith index, we may have chosen some values. So we have to check whether the value that we chose before does not lie in this range, does not violate this condition. So suppose the value that we chose prior, the prior value that we chose is at the jth index. So the prior value that we chose is at the jth index. So we have to check whether the value that we chose before does not violate these conditions. Right? So the DP state will be something like this. So the DP state will be DP of I j. So I will be the current index that we are on, and j will be the index of the previous element that we chose. So it is necessary, and it is given that I and j can be up till 10 raised to 5. I and j can be up till 10 raised to 5. So I is 10 raised to 5 and j is 10 raised to 5. So the total value will be equal to 10 raised to 10. So it will be much. This will cause a very high time complexity and very high space complexity. So we can't use these two states. So we have to choose some other states. So the first state is important. So we have to keep track of the current index that we are on. So we know we can't lose this I state, I index. So what we can do is that we can make some modification to the j state. So what I did is that in the second state, so if we are standing on a particular index, what I did is that in the second state, what I stored is the difference between the value that we chose before and the current index that we are on. So suppose we are standing on this particular index, and the value that I chose before is this value. So in the second state, for j, what I will store is that j is equal to 1, 2, 3. So since this is the fourth index, this is the third index, I will get the value that the index that we chose before by subtracting I minus j. I minus j is equal to 3 minus 3 equal to 0. So the value that I chose before is at the 0th index. Okay, now you may ask me, okay, this is almost similar to the previous implementation, right? This is almost similar to the previous implementation where we chose j as the value of the index of the previously chosen value. No, actually it is not, because this j can at max go till 5. It won't go above 5. I will tell you why. This j can at max go till 5, and it won't go above 5. So that's the part that you have to think about. That's the part that you have to think about. So why doesn't go beyond 5? So we don't need to increment the j beyond 5. Till 5 is enough. Actually, till 4 is enough. Until 5 is enough. So it doesn't matter like 5, 4. So I will tell you why it doesn't matter if j goes beyond 5 or 4. So what was j again? J was the distance to the previously chosen value. So suppose we are on. Suppose the current index is on this particular value. So the current index is 0, 1, 2, 3, 4, 5, 6. So I is equal to 6. And suppose the previous index, the previous value that we chose is this 5. The previous value that we chose is 5. So that so the distance between the current index and the previous chosen index will be equal to 1, 2, 3, 4. J is equal to 4. So we can get the value of the previously chosen index by subtracting this I minus j. I minus j is equal to 2. So that's the index of the previously chosen value. 0, 1, 2. We got I minus j is equal to 2, and it's the value of the previously chosen index. And now I will show you why j can't go beyond 5. Why j can't go beyond 5. So to understand that, we will take this test case. We will take this test case. So for this test case, I will first convert it into the pair format that I told you about in this format. So to convert into that format, what I do is that I will create a new array, and inside that array I will add some pairs. So the first value of the pair will be equal to the value that we are choosing. The second value of the pair will be equal to the number of occurrences of that value. The number of occurrences of 2 is equal to 1, 2, 3, 4, 5. And then the next value is 3. The number of occurrences of 3 is equal to 1. 3, 1. The number of occurrences of 4 is equal to 1. The number of occurrences of 6 is equal to 1. The number of occurrences of 7 is equal to 2. So first we converted into this format. Now we are gonna perform the. Now I'm gonna tell you why can't j go beyond 5. So suppose we choose this value. Suppose we have chose this value, right? We have chose this value. So this is the worst case that I'm talking about. So I formed this test case to talk about the worst case that j can go. So this is a worst test case that they can give you to test the limits of j, to test whether you have given the right value for j. So suppose you have chosen this first value. You have chosen 2, and you are the first index that you chose is this. So that total sum till now is equal to 2 into 5. The value that you chose is 2, and the number of occurrences of 2 is equal to 5. So the sum till here is equal to, the maximum sum till here is equal to 10. And now since you have chosen 2, you can't choose 3 and 4, because 3 is equal to 2 plus 1 and 4 is equal to 2 plus 2. So you can't choose these two values. You can't choose these two values. So the next value that you can choose is this value. So the distance till here is 1, 2, 3. The distance till here is 3. Right. So wait, I will add one more value. 8, 3 or 8, 2. It's fine. 8, 2. I'll add this to the my. One second. Actually, you don't need this 8 2. Just let it be there. So suppose if we are at this particular value, the distance till the distance from here till the last index that you chose is 3 right now. And suppose if you decide not to choose this value, if you decide, okay, you are at this current index, you have the option to either choose this value or not choose this value. Okay, sorry, I haven't I haven't added one value. I haven't added 5, right? Sorry, my mistake. I haven't added 5. There was a 5 over here and I forgot to add that. I will change it. So the values are 2 5 3 1 4 1 5 1 6 1 7 2. So you are currently at this particular index, and you have the freedom. You have the right to choose this 5 or not choose this 5. So if you are choosing this 5, the last value that you have chosen will become equal to this index, and the distance will get updated to 0. Right, since you are standing on this index and the last value that you have chosen is this index, this value, so the distance between the last chosen value will be equal to 0. But suppose you haven't chosen that particular value. You are in the dilemma whether you want to choose this particular value or not choose this particular value, and you decided to not choose this particular value. Okay, you may have foreseen, okay, if I don't choose this value and if I choose some value in the after this particular value, if I choose some value, I may get a much larger sum than that I get by choosing this particular value. So I have foreseen that I will get some higher value if I reject this value and if I choose some value in the later array. Right, but the only logical thing, the only logical thinking to not choosing this particular value will be either to choose this value or this value, right? So if we are choosing not to pick this particular value, it should be either to pick this value or this value. Otherwise, it makes no logical sense. So suppose if we are choosing not to pick this value, and if we are not picking this value and this value as well, we are not picking any of these values, it doesn't make any sense, because then we are losing out on all these 3 values. So if you were not going to pick this value and not want to pick this value, it would have been better if you had picked this value, because anyways you are not going to pick this value and not going to pick this value, and so you could have picked this value. So the bad thing about picking this value is that if you pick this value, you will not be able to pick this value and pick this value, right? So if you pick this value, you will not be able to pick this value and pick this value. But if you are not going to pick this value and not going to pick this value, the logical thing is to pick this value, right? I hope you understood. So suppose we are on this particular value, and either we can pick this value or not pick this value. If we pick this value, we can't choose this value or this value. But if we not pick this value, we can choose either this value or this value. But by not choosing this value, it may be because you are choosing either this value or either this value. If you do not pick this value and do not pick this value or this value, it doesn't make any sense. So if you are not going to pick this value or this value, it would have made sense to pick this value, add that to the sum, right? So that's the main logic behind this. That's the main logic behind this problem. So you are choosing not to pick this value, and you moved on to this value, and you decided not to pick this value, and you moved on to this value, and suppose you picked this value, now the distance will be equal to the distance from the last chosen value. The last chosen value is this. The distance to here from the last chosen value is equal to 1, 2, 3, 4, 5. So j will be equal to 5. So that's the main logic. That's why j can't go beyond 5. That's the reason j can't go beyond 5. So this is the main logic behind the problem. Hope you have understood it. So I will tell you again. So the main thing is that when you have raised this value, if you are not gonna pick this value, it's because either you are gonna pick this value or not gonna pick, either gonna pick this value or gonna pick this value. If you don't pick this value and don't pick this value and don't pick this value, it doesn't make any sense. So if you know that you are not going to pick this value or not going to pick this value, it's better to choose this value, right? So that's the main logical reason behind this problem. So I will show you the code for the problem right now. The code is also very simple. Now I will show you the code. So the code for the problem is, it's very simple. So what I did is that I created a new vector vec where I made pairs, and such that the first value of the pair will be equal to the value, and the second value will be equal to the number of occurrences of that particular value. And I created a dp vector, and then I started the recursive function. And inside the recursive function, if I is equal to the if I exceeded the vector bounds, I returned 0. If we have already encountered that particular state, we are returning the value of the already stored value. Otherwise, if j is equal to 0, we have the option, j is equal to 0, we have the option to either pick the current value or not pick the current value. So if we are picking the current value, then we are moving on to the next index, and since we are moving on to the next index, the distance between the last pick value and the next index will be equal to 1, right? So since we'll be going to the next index, and we have picked the ith index, and we are going to the i plus 1 index, the distance between the last picked and the current picked value will be equal to 1. That's why I'm doing it over here. So if I'm not gonna choose any values, the j will remain as such. Otherwise, if j not equal to 0, so actually j will be equal to 0 will be only for the starting case. After that, j will have some values other than 0. If j not equal to 0, what I'm gonna do is that I'm gonna check whether the difference of the vec of I minus j, the value at the vec of I minus j and the value at the current index is greater than or equal to 3. Actually, you can write this as greater than 2 to satisfy the conditions that were given in the problem. These conditions, to satisfy these conditions, if it is satisfying those conditions, we can take the take their particular value into our total sum, into our total answer. So this is the value, and this is the number of occurrences. So the value into the number of occurrences will give you the total value that you will get after choosing the ith index. And then we are iterating to the next index. If j less than or equal to 4, we have the option to not pick the current index. If the distance between the current index and the last index that we chose is lesser than or equal to 4, we have the privilege to not pick the current index. So that's what I was explaining about in the last part. Yeah, so this is basically the solution to this problem. Now I will post the solution to the last problem as well. Thank you. And one more thing, like if you have understood the solution, please comment down whether you have understood or whether you have not understood. It would help me in correcting my mistakes next time. And also, if you have understood, please like and subscribe. Thank you.